Thanks, it's great to be here. I'm very excited. I even have some students that I had in my class last quarter, so that's very fun. So I don't know if you see this classroom. Does that look fun? I think we've all seen elementary school students, high school students, and college students not engaged, not excited about learning. And even myself, and I have to say, what does a degree mean if you're not excited about learning and not asking new questions? So for me, in my high school class, I'd much rather be out than in this classroom. Until I had this amazing biology teacher. He asked us interesting questions. He inspired us to think. He got us out in the field, designing our own experiments, and just wanting to learn. So I went from an uninterested student to wanting to learn everything. So I worked hard. I earned a bachelor's of science and a PhD in chemistry. And now I'm very fortunate to be here at UCSB working with thousands of students every year. I love teaching general chemistry. First of all, there's a wide variety of topics and lots of applications to the materials, life, and the environment. There's always news that I can bring into the classroom that relate to whatever we're learning. And we have a wide variety of students in the class. We have majors, all majors of science, engineering, and humanities in the same class. I love interacting with the different types of people. There is a challenge. The level of preparation is very different among these students. Some have had 2 years of chemistry in high school, honors, AP, and a 5 on the AP exam. Other students don't remember being in the classroom and have no idea what they learn in chemistry. So we do have an online homework assignment that reviews chemistry so that they're ready when they come into the first day of my chemistry class. But even so, there are students who feel very overwhelmed. I have lots of questions and discussions, and they feel like they aren't going to be able to compete. So how can we challenge all students without overwhelming the less well-prepared students? Well, here's a student, Brooke Vanderstoop Hunt. She came into my office and sat down and said, okay, I'm really worried. I'm on probation. I have to pass your class. I have to pass all my classes to be able to remain a student at UCSB. How can I possibly make this work? And I said, no problem, as long as you're willing to work. So she worked hard. And we talked about time management, problem solving every day. And I send out a class email 2 days before each lecture so that students can prepare for the discussions in class. They can do the problems and the reading that I think is important to get ready for a certain lecture. So they're really engaged when they come to class, and when they discuss, they can teach each other. So she was doing that. She got average on the first exam, which makes sense because she was starting from basically 0. And then by the final, though, she kept working and got an A. And since it's comprehensive, she gets an A in the class. Second and third quarter of general chemistry, she got the only perfect score on the final. So this is pretty amazing progress. And she was so excited about learning that at this point, she loved science. She had no idea that she was going to like science this much. She is now a straight A student. And she says to me, I'm ready to do research. So she comes into my office, and we look at faculty web pages to see what she might be interested in. And she says, I want to work for this guy, Kevin Plaxco, a professor in biochemistry. And she starts working on these biosensors to screen for HIV and other infectious diseases. Building this requires engineering. It requires knowledge in biology and chemistry. So she's working with a team to build these. And you can, because they're handheld, you can easily take them to underdeveloped countries and actually use them without too much of an issue. She continued to do well throughout her career at UCSB, and graduated with honors, gave the commencement address, and now is doing cancer research, finishing up her PhD probably this year at Stanford University. So I think this is amazing. So my question is, what happened here? How can we empower young minds? How can we harness potential of students today for tomorrow? Well, I think students shouldn't only be in the classroom. So we want to give students the opportunity to both learn and teach. And I think by teaching, they learn a lot more. So we have this outreach program that we started about 15 years ago now and then, and we have these amazing volunteers in our program. And one volunteer last year came through as a 5th grader in the program and now is a volunteer. I love that. So every Thursday morning, we have 2 5th grade classes come out, and our undergraduates volunteer to work with the 5th graders. And we have one of our volunteer coordinators here who just, it's an amazing, exciting, and the undergrads are excited to be there and share their enthusiasm for science, and the 5th graders just all want to become chemistry majors after they go in this lab. They're in the lab for an hour and a half. They do hands-on activities that are all standards-based, and they're just engaging and fun, and they do a lot of learning in the lab. There's about 1,400 students per year that visit the chemistry lab, and I want to show you one of the activities. So here's one of the activities that we do, and Dr. Price is going to help me do this. So this is, we're just showing you, this is methane gas, and we asked the students, so what's happening with this bubble of methane gas? Oh, first of all, it floats up. So the students are learning about densities of gases and what is methane? What is air? Then a 5th grader, what's amazing about 5th graders is they ask interesting questions. One 5th grader goes, well, what is fire? I mean, we're used to seeing wood burn, we're used to seeing a candle burn, but what is this floating fire in the air? So the undergrad goes, yeah, what is fire? Well, let's observe again. So you observe again, and the 5th grader goes, oh, I know what it is. Fire is heat and light. I feel it, and I see it. So he's done. Thank you. So what do we use fire for? Well, heat our homes, power our cars, whatever. But we need to think about, where does the heat come from? And where does the light come from? But then, and here's the undergrads doing it, or with the 5th graders. And the 5th graders get to light the bubbles, and they can't believe, you know. One 5th grader, after this lab, they go, is this place for real? Like, if I come to the university, I get to do this? Okay. So, but they enjoy it. Then they actually get to use the heat. What we do is the cost for the students to come do our program is 2 shiny pennies. And they actually get to take them home. So they take their pennies and put them in a zinc sodium hydroxide solution and coat them with zinc. Then they take it and put it in the flame of a Bunsen burner. And then what happens is the copper and zinc mesh and make brass, the alloy. And that's actually one of the California standards. They have to learn about alloys. So what they get is 3 pennies, a copper, zinc, or what they call silver, and a gold penny, which is really brass. So it gives us an opportunity to talk about all kinds of chemistry when we do this. So I'm going to do science. This is what one student said to his mother after he visited the lab. 2 years later, she said, I had to take off work today to see what happens. She came with her 2nd son. What happens in this lab? Because my older son came here, and he was having learning issues, And after the lab, he just decided he was going to do science and is working hard in school, and now he's in honors science. So she was stoked. So, and this actually, Michael Kwok, was an amazingly dedicated volunteer. And he came every Thursday morning, no matter what. And he just graduated from Tufts Medical School. And because he missed outreach, would have his medical students, he started a whole outreach program with medical school students going into the classrooms where they were. So he was really amazing. And another outreach volunteer and coordinator was Kathy Tran. So we have the 5th graders, and Kathy's right there. She was a person, in case you wondered, she was an amazing person who came to UCSB and said she was not going to do science. She did not have a good experience in high school and was not going to do science. However, during the summer orientation program, she had to go to a faculty lecture, which happened to be my lecture in chemistry. And she goes, oh my God. No. So she came to this lecture, and I did lots of demonstrations and discussions and questions and answers and advice and to succeed at UCSB, and she loved it, and she goes, uh-oh, I think I have to take this chemistry class. So she ended up taking all sorts of science, did a degree in biopsych, and minored in journalism, and she got the highest award. She did undergraduate research, she did a senior thesis project, did research at UCSF, and was awarded the highest science awards on campus. So this is a person who was not going to do science, right? So she was hired as a writer for the Journal of Science right after school, went to Harvard and got a master's in technology, innovation, and education. And then now she's finishing up a PhD in learning, cognition, and development in science and math education. She's really working on how to motivate the science and math, and by motivating it, letting the cognition, improving the cognition. So what I like is building a whole community of learning and teaching. So we're not just learning by ourselves. The 5th graders are learning with the undergrads, are learning with the faculty and the 5th grade teachers. Everybody together is better than doing things separately, because we all learn from each other. I've learned so much from 5th graders and from 5th grade teachers. We work primarily with schools that serve large numbers, between 50 and 95% underrepresented minorities, English language learners, and economically disadvantaged students. Nancy Escamilla, who teaches 5th grade at E.P. Foster Elementary School in Ventura, California, has a class like that. Over 50% English learners, English language learners. That's a difficult situation to be in, and have them do well in class. Here they're doing a science fair where they did the projects. Her son Ali is helping, and the students were so enthusiastic telling me all about their projects. Now, before 2004, there was no science. Okay, there was no science. The main focus was math and language arts. Now look at their scores in 2004. Below basic, most of the students, a few students are proficient and above for the science. Not good. Well, Nancy decided she's going to attend our professional development science workshops in the summer, which was great. So she came and started doing hands-on science. They learn science content as well as activities that are appropriate for their grade level. Look what happens when we have hands-on science in the class. The proficient and above just increases dramatically when they're doing hands-on science and they're enthusiastic about what they're learning. What's even better about the scores is if you look at their lab notebooks. It's amazing how much they write and understand. By writing, they process. So Nancy makes sure she integrates the math and the language arts with the science, and look what happens to the math scores. Okay, math scores, proficient and above, huge increase. She also integrates with the language arts, huge increase. Okay, so science is an amazing motivator to get students to think and learn and want to do it and want to write. So these are amazing results. Another thing that's so great, I think, about this program is it's supported by the whole community. There's local foundations. Janet Sands has been amazing in letting us connect with all these local foundations. We have California Science Project, the National Science Foundation, and our Department of Chemistry and Biochemistry, all wanting to have this happen. So I'm really happy to be part of this program. I want to ask another question. So here we're burning methane. When we burn hydrocarbons, fossil fuels, what is one of the products? Carbon dioxide. Is that sustainable? Is this a problem? Now, if we go to an American Chemical Society website, which is an amazing place to learn all kinds of climate science, they have this graph of CO2 in our atmosphere over the last 2,000 years. Look what happened. It was pretty steady most of the time until the Industrial Revolution, and we see it skyrocketing. So, is this sustainable? What is actually happening? Now, I'm going to show you, here's just some water, and I'm going to put a little tiny bit of indicator that allows us to see acidity in the water, okay? So now the solution is nice and red, and it's neutral, because all we have in here is water. And I'm going to add a little bit of solid carbon dioxide, which we call dry ice. You can actually get this at stores, so if you want to do this at home, you can. Okay. And we have this reaction going on. Now, what happens? Let's see what happens. And it doesn't work. No. It will work. So what is happening with the CO2? We've always had CO2 in the air, in the atmosphere, and water absorbs. Our oceans and lakes absorb CO2. But now we're putting an excess amount of CO2 in the water, and slowly what we will see is a color change. And the color change from red to yellow, it's slightly orange now, is due to the water turning acidic. When the water is acidic, what happens? Our plant life, our animal life, and the coral reefs cannot be sustained. So this is not sustainable. And that's why at the university, we now have a new center for sustainability. It's called the Center for Sustainable Use of Renewable Feedstocks, and it's an NSF Center for Chemical Innovation. So I'm part of this center. And in fact, it's, again, a team. We have undergrads, graduate students, faculty from UC Santa Barbara, UC San Diego, UC Davis, and Washington University at St. Louis. So we all work together to do research and education. And what we want to do is where carbon dioxide is being produced and put in the atmosphere, we want to take it out of the atmosphere and convert it to carbon-based compounds that we can use. We also want to break down plant material in waste plants, or plant matter in waste plant material. So for example, wood chips, or just waste plants. So this is what we can do. And we also do outreach. There's another outreach program through chemistry called SciTrek. And Darby Feldwin and her students go out to the schools where they get the students to do long-term investigations where students design their own experiment. So our CenSurf collaborates with SciTrek, and you can see the students are trying to see what carbon dioxide or the properties of carbon dioxide by using animals, plants, light, dark, so they're understanding how carbon dioxide functions and about carbon dioxide in the atmosphere. So science is all about asking questions, designing experiments, discovering answers, and asking new questions. So empower young minds, ask them questions, listen to their questions, their ideas, and let them discover answers. I hope that all students find something that they're excited about. Thank you.